So we've got a container of liquid. What we're saying here is that we have a minimum of 5 inches of liquid, which is our zero value. We're going to set our maximum to 25 inches of liquid, which is going to be our maximum value. That's going to be proportional to a 4 to 20 milliamp signal that the level transmitter will transmit to the level indicator controller, the controller. So the controller is reading a 4 to 20 milliamp signal. That 4 to 20 milliamp signal is proportional to the level of the liquid in the container. Now the output side here, the controller outputs a signal that's proportional to the error, and the error is what you have minus what you want. So your set point is what you want, the actual level is what you have. It generates an output proportional to that. That also is a 4 to 20 milliamp signal, converts that into a 3 to 15 psi signal. That 3 to 15 psi signal modulates the valve, which either opens it or closing it so that there's more or less liquid going through. But before we talk about all of that, this is how this whole system works. I'm going to give you a scenario just to learn how to convert between signals. So this is a scenario. If the level transmitter transmitting a 12 milliamp signal to the controller. So what we're talking about here, if we're saying the level transmitter, we're talking here, and it's transmitting a 12 milliamp signal to the controller here. Inches of water is there in the column of water. Okay. And just to be sure that you know what the signals that we're using are, we are using a 4 to 20 milliamp system. The zero value is 5 inches of, let's just say, water, and the maximum level is 25 inches of. So that's what we have. We have a container. The min is 5 inches. The max is 25 inches. So the signal being sent to the controller, which represents the 5 to 25 inches of liquid, is a 4 to 20 milliamp signal. So what we have to do to find the value of how many inches that represents, we have several steps. Up a little bit. Right, step one. What we want to do first is find the percentage, the span. And that is your PV, which is your process value or present value, which is what I'm giving you. In this case here, the PV is 12 milliamps. That's the value I'm giving you. Okay. So PV minus the min, and that's going to be divided by max minus min. It's going to go here. Max. Okay, so you've got an equation here. Okay, so percentage, how do you get it? PV minus min over max minus min. So where do we go from here? Well, from here, what we're going to do is we're going to say, okay, what is my PV? Well, my PV is 12 milliamps. We're going to subtract the min, which is 4 milliamps. Why is that the min? Well, we have a 4 to 20 milliamp signal. So if we have a 4 to 20 milliamp signal, the min is 4 milliamps, the max is 20 milliamps. So PV, the given value, 12 milliamps minus 4 milliamps over max minus min. What's max minus min? Well, the maximum of a 4 to 20 milliamp signal is 20 milliamps minus the min, Again, it's 4 milliamps.
Sir, isn't it the zero the min value?
The zero value is the minimum value,
So how come you
which
said
is it's
5?
4. 4. No, we're trying to find the percentage of what is the percentage that 12 milliamps is within a 4 to 20 milliamp signal. That's the percentage we're looking for. So this has nothing to do with water yet. We're trying to get the percentage. 12 milliamps is what percentage of this range, okay, or this span. So bear with me. So if we do the math here, we end up with got 12 minus 4, which is 8 milliamps. Over 60 milliamps. All right, and that gives us 50%. That is step 1. All that does is it tells us that the level transmitter is transmitting a 12 milliamp signal. That 12 milliamp signal, okay, is half or 50% of the span. What span? The span is max minus min of the range. So a 4 to 20 milliamp signal, 20 minus 4 is 16. 12 milliamps is half of the 16 milliamp range. So it's at 50%, but that's only step 1. We still have 3 more steps to go to get the answer here. Okay. So I'm going to go with step number 2. Step number 2 is going to be, you've got to calculate the span of the variable you are converting to. What are we converting to? We want to take that 12 milliamps and we want to know how many inches of water is that. So if we know that 12 milliamps is 50% of a 4 to 20 milliamp signal, well, that means that the level in the container of liquid, that 50% of that amount is what we want to calculate. So 12 milliamps is equal to what? Well, what is 50% of the span between 25 and 5? So we have 3 more steps to go. And I'm breaking it down. I mean, eventually you can take some shortcuts here, but this is just to make you understand how the actual conversion works. Converting to, so in this case here, we're looking at water, H2O. So what is the span? Span is equal to max minus the min. So what is the maximum amount of liquid that we have? We have 25 inches. What is the minimum we have? We have 5 inches. That gives us a span of 20 inches of H2O. So we got step 1. We're given a value, a PV, that was 12 milliamps. 12 milliamps within a 4 to 20 milliamp signal is 50%. Then we have to figure out, because we want to convert this 50% or apply it to the inches of liquid, but we have to figure out what the span is. What is the span? The span is max minus min, which means that the span between the maximum 25 inches and minimum 5 inches is 20. That's how much you can move, 20 inches. Now, step 3 is you apply the percentage you calculated to the span you just calculated. 40, we'll call it the column of liquid. So take the span that you just calculated, and you take the multiplication times the percentage. So what is the span? The span was 20 inches. We're going to multiply that by what we calculated before, 50%. That's going to be equal to inches of H2O. Okay, so just to make sure that you know where these numbers are coming from, the percentage here is coming from this calculation. The 20 inches here is coming from this calculation. Okay? And you get 10 inches, but that's 10 inches, but it doesn't really give you how many inches are basically in the column of liquid, because you're not starting at 0, you're starting at 5. So you have to offset this 10 by 5, because it's 10 inches of the span. But the span, or the range, starts at 5 inches, not 0. So the last step we have to do is we're going to add the minimum. Does that mean add the minimum? We're going to take the 10 inches, H2O, and we're going to add minimum. So what do we get? We have 10 inches. We're going to add the minimum, which is 5 inches. Okay. And I'm not making these numbers up. We had said that we have a minimum of 5 inches of liquid here. So the answer is 15 inches of H2O in the column of liquid. And that represents the 12 milliamp signal that the LT, or level transmitter, is transmitting. Okay. So we started off with 12 milliamps. This 12 milliamps that the level transmitter is transmitting, this is transmitting 12 milliamps. Well, if you're measuring this as an electrician with your multimeter on amps, you measure 12 milliamps, well, you should know, based on your calculation here, that you should have 15 inches of liquid, and which represents 50% of the span between the max and the min. Okay, so we've taken the 12. The first step was 12 milliamps. Well, what percentage is that within this span? Because it's proportional. So that was 50%. So if we apply that 50% to the span of the inches of liquid, well, what is the span? 25 minus 5, which is 20. We take that 20, multiply by the 50%. We have 10 inches, but that's 10 inches within the span, but we're not starting at 0, we're starting at 5 inches. So we add the 5 inches, and we're at 15 inches of liquid.